Welcome to qnawire.
For this problem, we want to use Stokes' theorem. Stokes' theorem is very helpful because we can switch between double and single intervals or vice versa. But we can rewrite this based on what we were given. This is the Stokes' theorem kind of formula that we go off of mainly. And we can now use Stokes' theorem where C right here is going to be the boundary of the surface oriented counterclockwise. So it will be helpful for us to look at what we're given as the integral of z negative 2x 3y dot dx dy dz, which is going to be the same as the integral of f dot dr. With that in mind, we see that the curl of f, since we know that this is f right here, the curl of f, when we calculate it, we'll have the partial derivative of r with respect to y. So that'll be 3 minus the partial derivative of q with respect to z, which will be 0. Then we'll have the partial derivative of p with respect to z, which will be 1, and then minus the partial derivative of r with respect to x, which is 0. Then the partial derivative of q with respect to x is negative 2, minus the partial derivative of p with respect to y, which will just be 0. So with all this in mind, we see that the curl of f is going to be 3, 1, negative 2. So now that we have the curl of f, we want to also note that ds is equal to the normal vector ds. So when we take this right here, it will ultimately be the same as this right there. So because of that, we want to determine our normal vector n. Since x plus y plus z equals 1, we see that our normal vector is equal to 1 over the square root of 3 times this vector right here. So as a result of that, what we'll have is this being set equal to this times the double integral of 3, the f, so 3, 1, negative 2, and then f dot our normal vector, which is 1, 1, 1, and then we already moved the 1 over root 3 out here, ds. So then when we take the dot product of this, it'll be 3 plus 1 minus 2, so that will just end up giving us a 2, which we can pull out and put up here by multiplying. Since we know that this right here is the area inside the loop C, we can just call it A. So that tells us that this whole thing will be equal to 2a over the square root of 3, and that will be our final answer. And A would be the region enclosed by the smooth curve C.